Picture this: a single image, captured in the infinite darkness of space, rewrites everything we thought we knew about the cosmos. It's not just a snapshot, it's a revelation, a forbidden peek at something so extraordinary it wasn't meant for our eyes. Not yet, not now. In August 2025, NASA's Sphere-X telescope, a marvel of infrared observation, caught a fleeting moment that has left astronomers across the globe reeling: a massive blood-red coma enveloping an object dubbed 3I Atlas. This is no ordinary comet, drifting lazily through our solar system with a familiar tale of ice and dust. No, 3I Atlas is a cosmic renegade, venting carbon dioxide at an astonishing 70 kilograms per second, defying every model we've painstakingly crafted to explain celestial wanderers. The image, kept under wraps for weeks before its quiet release, shows a glowing sphere of CO2 stretching across the void like a warning. Why did NASA hold back this discovery? Why shroud something so monumental in silence? Is 3I Atlas merely an oddity, or does it hint at something far more unsettling? Buckle up, because this journey through the stars will grip you, challenge you, and leave you questioning what lies beyond the veil of our understanding. Let's rewind to August 2025. Sphere-X, NASA's cutting-edge infrared telescope, locks onto a distant speck 3.2 astronomical units from the Sun, roughly Jupiter's orbit, about 480 million kilometers away. At this distance, comets typically stir to life. The Sun's faint warmth kisses their icy surfaces, turning frozen water into vapor, birthing tails that stretch across the sky like cosmic banners. It's a celestial dance, predictable and ancient. But 3I Atlas refuses to join in. Instead of water vapor or dust, Sphere-X reveals a colossal coma, a spherical shell of gas 348,000 kilometers wide, nearly the distance from Earth to the Moon. Imagine that, a glowing, blood-red sphere so vast it could swallow our planet and reach our lunar neighbor. This coma, composed almost entirely of carbon dioxide, vents the equivalent weight of a human every second. Yet there's no ion trail, no water sublimation, no chaotic jets slicing through the solar wind, just a smooth, eerie halo of CO2. Comets don't behave this way. At 3.2 astronomical units, water should reign supreme, creating pressure, driving jets, and sculpting the iconic tails we've studied for centuries. But 3I Atlas is silent, its water ice locked beneath the surface, entwined with organic compounds, stubbornly dormant. Why? The mystery of this silent giant grips us, pulling us deeper into the unknown. The data is undeniable, but the explanations are elusive. Scientists are racing to unravel this anomaly, grasping at theories that feel like fragments of a larger truth. Some propose that the CO2 acts as a thermal blanket, cooling the surface and preventing water ice from sublimating into vapor. Others suggest the water is buried deep beneath layers of dust and ice, too insulated from the sun's warmth to react. But these ideas don't fully fit. The coma is too large, too symmetric, too consistent to be a chaotic plume of escaping gas. It's structured, almost deliberate, like a beacon pulsing in the void. Researchers have begun comparing 3I Atlas to cold comets from the Kuiper Belt or Oort cloud, distant reservoirs of icy bodies at the edge of our solar system. Yet even those comets don't emit CO2 in such massive quantities or with such eerie regularity at this distance. The scale is wrong, the behavior is wrong, and the silence is deafening. Is 3I Atlas a comet at all? Could it be an interstellar visitor forged in the fires of a distant star? Or is it something we lack the language to define? The questions pile up, each one a spark in the darkness, urging us to keep searching for answers. If the coma is a riddle, the core of 3I Atlas is a crisis for everything we know about the cosmos. When Hubble first spotted it, estimates were modest. A nucleus perhaps 300 to 500 meters wide, akin to Comet 2I/Borisov, a small, cold, predictable object. But Sphere-X's near-infrared data shattered that assumption. Scientists detected an unusually strong flux at 1 micron, a wavelength of reflected light far too intense for a tiny nucleus. They ran the models, checked and rechecked, and arrived at a staggering conclusion. The nucleus could be 46 kilometers across. That's not just large, it's apocalyptic. For perspective, that's larger than 90% of known comets, making 3I Atlas over 1 million times more massive than Borisov. An object this size should have been impossible to miss. Its gravitational pull would bend the light of distant stars in a phenomenon called microlensing. Its coma, laden with dust, should have painted the sky with scattered sunlight. Yet 3I atlas stayed hidden until recently, revealed only by its glowing red coma. How could something so massive remain unseen? The paradox is maddening, and it's forcing us to question the very fabric of our observations. This contradiction birthed a second hypothesis. What if we're not seeing the core at all? What if the brightness, over 99% of it, comes from microscopic particles in the coma, reflecting sunlight like a cosmic mirror? This would shrink the nucleus back to a more familiar size, perhaps a few hundred meters across. But here's the catch. Where's the dust? A coma dense enough to mimic a 46-kilometer nucleus would require an immense cloud of particles. Yet Hubble sees no extended dust cloud, no tail, no jets. The reflectivity curve is even more perplexing. It's too smooth, too symmetric, suggesting a surface that's almost polished, not a chaotic swarm of debris. Astronomers call this symmetric reflectivity, a pattern that hints at a consistent, almost controlled structure, not one battered by eons of cosmic erosion. So what are we dealing with? A massive icy body cloaked in its own dust, a smaller object buried in a deceptive cloud, or something else entirely, something with a geometry that defies the chaos of nature. The deeper we peer, the stranger it becomes, and the silence from 3i Atlas only amplifies the mystery. Spectral data offers another clue, but it's one that raises more questions than answers. Water ice is present in 3i Atlas's nucleus, locked alongside CO2 and organic compounds, like a frozen memory of its origins, but it's not behaving as it should. At 3.2 astronomical units, water ice typically sublimates, boiling into vapor and driving the birth of a comet's tail. Yet 3i Atlas is stubbornly quiet, emitting just 4.5 kilograms of water vapor per second, a tenth of what similar comets release at this distance. It's as if the object is refusing to wake up, or perhaps concealing something beneath its surface. Some models suggest the CO2 is cooling the surface, preventing water from vaporizing. Others propose the water is buried under thick, insulating layers of dust, or that the surface chemistry is fundamentally different, alien even, but none of these theories fully explain the scale, the symmetry, or the silence. The water is there, but it's locked away, a secret 3i Atlas isn't ready to share. This anomaly challenges everything we know about cometary behavior, pushing us to rethink the rules of the solar system. And then there's the timing. SphereX collected this data in early August 2025, but NASA didn't share it publicly until weeks later, slipping it into a quiet update on their blog. No press release, no fanfare, just a few understated paragraphs buried among routine mission reports. Why the delay? Some argue it's standard protocol, a cautious step to verify the data before making bold claims, but others see something more suspicious. This isn't the first time we've encountered an object that doesn't fit the mold. In 2017, Oumuamua streaked through our solar system, behaving like a comet but without visible gas. It accelerated without propulsion, tumbled without explanation, and vanished into the void. 3i Atlas feels like a sequel, bigger, brighter, closer. Most scientists insist it's a natural object, an outlier but not an anomaly, yet a small vocal minority, including Harvard's Avi Loeb, points to the symmetric reflectivity, the unusual trajectory, and the missing tail as evidence of something more. To them, 3i Atlas isn't just a comet, it's a clue perhaps to technology rather than nature, something made, not formed. The silence from NASA only fuels the fire, making us wonder what they know, and what they're not telling us. Let's pause to consider the stakes. If 3i Atlas's nucleus is truly 46 kilometers across, its mass could have catastrophic implications if it ever veered near Earth. Even if it's smaller, the sheer volume of CO2 it's venting raises questions about its origins. Could it be an interstellar visitor forged in a distant star system? Its composition, rich in CO2 and organic compounds, hints at a chemistry unlike anything in our solar system. The symmetric reflectivity suggests a surface too uniform, too polished to be the product of billions of years of cosmic wear. And NASA's delay in sharing the data, it's a spark that ignites speculation. Is it caution, or is it something they're not ready to admit? As 3i Atlas drifts closer to the sun, toward its moment of truth, the questions multiply. Will its water ice finally sublimate, forming a tail and confirming its cometary nature? Or will it continue to defy expectations, venting CO2 and eerie symmetry, its core shrouded in mystery? The sky doesn't lie, but it doesn't always reveal the whole truth. For now, we watch, we wait, and we wonder. Is this a relic from another star, a natural oddity, or something more? A signal, a structure, a visitor? This is where you come in. The universe is brimming with mysteries, and 3i Atlas is one of the most captivating yet. If this story has ignited your curiosity, hit that like button to let others know this cosmic puzzle is worth exploring. Drop a comment with your thoughts. What do you think 3i Atlas is? A comet, an interstellar oddity, or something we can't yet fathom? Subscribe to stay on this journey as we chase the truth beyond the headlines. The cosmos is calling. Let's answer together. Let's plunge into the science behind 3i Atlas, because the numbers weave a tale as gripping as the visuals. The coma, that blood-red sphere of CO2, spans 348,000 kilometers. Imagine a glowing cloud that could engulf Earth and stretch to the moon. It's not just the size that's staggering, it's the composition. Most comets at 3.2 astronomical units release water vapor as their primary gas, driven by the sun's heat. Water sublimates, creating pressure that blasts jets of gas and dust into space, forming those iconic tails. But 3i Atlas vents 70 kilograms of CO2 per second with just 4.5 kilograms of water vapor, less than 7% of its output. Compare that to Comet Hale-Bopp, which released water at 10 times that rate at a similar distance. This CO2 dominance is unprecedented, upending everything we know about comets. The coma's symmetry is another enigma. Cometary comas are typically chaotic, shaped by uneven outgassing as the nucleus rotates, exposing patches of ice to the sun. Jets erupt, dust scatters, creating lumpy, irregular clouds. But 3i Atlas's coma is nearly perfectly spherical, suggesting a controlled, uniform release of gas. Scientists hypothesize a porous subsurface mantle allowing even gas escape, or a nucleus so smooth it lacks the craters and fissures that disrupt outgassing. Yet these ideas stretch credulity. No known comet behaves this way. The Kuiper Belt and Oort cloud produce CO2-rich comets, but never in such quantities or with such regularity at this distance. The organic compounds detected in the nucleus add another layer. These carbon-based molecules, potential seeds of life, suggest 3i Atlas could be a messenger from a distant star system with a chemistry unlike our own. The lack of dust, the absent tail, and the coma's eerie symmetry challenge every model, forcing us to rethink the chemistry of the cosmos. Now, let's confront the nucleus, the heart of this mystery. Hubble's initial estimate pegged 3i Atlas's core at 300 to 500 meters wide, a speck akin to Comet 2 I/Borisov. But SphereX's infrared data upended that, detecting a strong flux at 1 micron, reflected light too intense for a small nucleus. Models converged on a shocking size. 46 kilometers across, larger than Mount Everest is tall, dwarfing 90% of known comets. This makes 3i Atlas over 1 million times more massive than Borisov. An object this size should have been spotted years ago, its gravitational pull warping starlight via microlensing, its dust-filled coma scattering sunlight across the sky. Yet it remained invisible until recently, betrayed only by its red coma. An alternative theory suggests the brightness comes from microscopic particles in the coma, reflecting sunlight like a mirror, shrinking the nucleus to a few hundred meters. But where's the dust? Hubble sees no cloud, no tail, no jet. The reflectivity curve is too smooth, too symmetric, suggesting a polished surface, not a chaotic swarm. Could the nucleus be a cohesive object with a reflective layer of frozen CO2 or organics? Or something stranger, a structure, not a natural body? A 46-kilometer nucleus could disrupt asteroid orbits if it neared the inner solar system. Even a smaller reflective core challenges our understanding of cometary surfaces. NASA's delayed data release, weeks after collection, adds fuel to the mystery. Was it verification or something more? The nucleus holds the key, and each observation pulls us closer to or further from the truth. The comparison to Oumuamua is unavoidable. In 2017, that cigar-shaped interstellar visitor rewrote the rules, moving too fast, accelerating without visible propulsion, and vanishing without answers. 3i Atlas feels like its bolder successor. Where Oumuamua was faint and fleeting, 3i Atlas is vivid, its coma a glowing beacon. Its trajectory, while less erratic, shows subtle deviations hinting at unseen forces. SphereX and Hubble data are vital, but so are observations from amateur astronomers tracking it at coordinates RA 14 hours 32 minutes, DEC -5 degrees 12 minutes, as of September 2025. On X, hashtag 3i Atlas trends globally, with posts ranging from scientific analyses to theories of alien megastructures. The parallels to Oumuamua, unusual trajectories, missing out gassing, and debates over artificial origins are striking. Harvard's Avi Loeb, who suggested Oumuamua might be a probe, sees similar signs in 3i Atlas's symmetry and behavior. The scientific consensus favors a natural explanation, but the possibility of something artificial lingers. Could 3i Atlas be part of a pattern of interstellar visitors challenging our assumptions? The search for extraterrestrial intelligence thrives on anomalies, and 3i Atlas is a glaring one. As SphereX, Hubble, and possibly the James Webb Space Telescope continue observations, we're not just studying an object, we're probing the boundaries of the possible. Let's zoom in on the chemistry, because it's a window into 3i Atlas's origins, and perhaps the origins of life itself. The spectral data reveals organic compounds, carbon, hydrogen, oxygen molecules that are the building blocks of life as we know it. Comets are often called the seeds of life, delivering water and organics to early Earth billions of years ago. 3i Atlas, with its CO2-heavy coma and organic-rich nucleus, could be carrying a similar payload, but from a star system far beyond our own. The dominance of CO2, 70 kilograms per second compared to a mere 4.5 kilograms of water vapor, suggests a formation environment unlike our solar systems. Perhaps it formed around a star with less water, or in a region where CO2 dominated the primordial chemistry. The symmetry of the coma, almost too perfect, hints at a process we don't fully understand. Perhaps a subsurface reservoir releasing gas evenly, or a surface engineered to resist the chaos of outgassing. The lack of dust is equally baffling. Comets typically shed dust as they sublimate, creating tails that glow in the sun's light. But 3i Atlas's coma is clean, its reflectivity suggesting a surface that's almost mirror-like. This could point to a unique composition, perhaps a layer of frozen CO2 or organic polymers that scatters light uniformly. Or it could suggest something artificial, a surface designed to reflect rather than erode. The organic compounds raise tantalizing questions. Could 3i Atlas carry the chemical fingerprints of a distant world, one where life, or its precursors, once existed? The data as of September 10th, 2025, offers no clear answers, but it challenges us to rethink the role of comets in the cosmic story of life. Every spectrum, every measurement is a piece of a puzzle that could redefine our place in the universe. The public's reaction to 3i Atlas has been nothing short of a phenomenon, turning a scientific discovery into a global obsession. On platforms like X, the hashtag number 3i Atlas has exploded, trending worldwide as of September 10th, 2025, with thousands of posts dissecting the data, sharing telescopic images, and speculating about everything from alien technology to government cover-ups. Amateur astronomers are pointing their telescopes at 3i Atlas's coordinates, capturing faint glimpses of its red glow and sharing them online, fueling a citizen science movement that's democratizing discovery. Professional astronomers, meanwhile, are urging caution, emphasizing that extraordinary claims require extraordinary evidence. But the public's fascination isn't just about the science, it's about the story. 3i Atlas has become a symbol of the unknown, a canvas for our hopes, fears, and curiosities. Its eerie symmetry and NASA's delayed release have sparked theories that echo the Oumuamua debates of 2017, when the world grappled with the possibility of an interstellar visitor that didn't fit the mold. On X, users share side-by-side comparisons of 3i Atlas and Oumuamua, noting their shared quirks, unexplained trajectories, missing outgassing, and a haunting silence. The cultural impact is undeniable. 3i Atlas has inspired art, memes, and even music, with creators imagining it as everything from a cosmic warning to a beacon of hope. This groundswell reflects a deeper truth. Humanity craves answers, and when institutions like NASA hold back, the public fills the void with imagination. As observations continue, with telescopes like SPHEREX and possibly the James Webb Space Telescope, 3i Atlas is no longer just an object, it's a shared journey, uniting scientists, amateurs, and dreamers in the quest for truth. As 3i Atlas drifts closer to the sun, the next few months will be pivotal. By early 2026, it will reach its closest approach, around 2 astronomical units, where the sun's heat could trigger water sublimation and reveal a tail, confirming its cometary nature. Or it might remain silent, venting CO2 in that eerie, symmetric coma, strengthening the case for something more exotic. NASA's planned observations with SphereX, Hubble, and potentially the James Webb Space Telescope will provide sharper data, possibly resolving the nucleus size debate. Ground-based observatories, like the European Southern Observatory, are also tracking 3i Atlas, their data complementing space-based findings. The Vera C. Rubin Observatory, set to begin full operations in 2025, could detect subtle changes in the coma's structure, offering clues about its composition and behavior. Amateur astronomers are vital too, their observations adding to a global dataset that's growing by the day. The question of whether 3i Atlas is natural or artificial hangs in the balance, and each new image, each spectrum, brings us closer to an answer, or deeper into the mystery. The silence from NASA, whether cautious or calculated, has only heightened the stakes, making 3i Atlas a test of our trust in science and our willingness to embrace the unknown. As we await the next chapter, one thing is clear: 3i Atlas is more than a comet. It's a challenge to our understanding, a call to keep looking up, and a reminder that the universe is full of surprises waiting to be uncovered. What if 3i Atlas isn't just a visitor, but a messenger from another star system, carrying secrets from a world we'll never see? Its composition, dominated by CO2 and laced with organic compounds, suggests a birthplace far different from our solar system's icy nurseries like the Kuiper Belt or Oort cloud. Most comets in our neighborhood form from a mix of water ice, CO2, carbon monoxide, and methane, with water leading the charge as they near the sun. But 3i Atlas's overwhelming CO2 output, coupled with its minimal water vapor, points to a formation environment where water was scarce, or CO2 was unusually abundant. Perhaps it was born around a star with a hotter, more carbon-rich protoplanetary disk, or in a region where volatile gases like CO2 dominated over water. The organic compounds detected in its nucleus are particularly intriguing. These complex molecules, chains of carbon, hydrogen, and oxygen, are the raw materials of life, potentially delivered to planets like Earth by comets billions of years ago. Could 3i Atlas be a cosmic courier carrying the chemical signature of a distant star system where life, or its precursors, once took root? Its symmetric coma, lacking the chaotic jets and dust trails of typical comets, suggests a structure that's almost too orderly, as if shaped by forces we don't yet understand. Some scientists speculate that its surface might be coated in a reflective layer of organic polymers or crystalline CO2, polished by eons of cosmic radiation. Others, like Avi Loeb, entertain the possibility of artificial design, a surface engineered to withstand the rigors of interstellar travel. The trajectory of 3i Atlas adds another layer. Its path deviates slightly from a purely gravitational orbit, hinting at subtle forces, perhaps from uneven outgassing, or something more exotic. As of September 10th, 2025, posts on X speculate about its origins, with some users suggesting it could be a fragment of a shattered exoplanet or even a derelict probe from a long-dead civilization. While these ideas push the boundaries of science, they reflect the profound questions 3i Atlas raises about our place in the cosmos. Whether it's a natural relic or something more, its presence forces us to confront the vastness of the universe and the possibility that we're not alone in it. The discovery of 3i Atlas underscores the incredible power of modern astronomy, where cutting-edge technology meets human curiosity to peel back the universe's secrets. SphereX, launched in February 2024, is a cornerstone of this effort, designed to map the infrared sky with unprecedented detail. Its ability to detect faint heat signatures made it the perfect tool to spot 3i Atlas's glowing coma, invisible to visible light telescopes like Hubble. But SphereX is just one piece of a global network of observatories pushing the boundaries of what we can see. Hubble's visible light observations provided the first glimpse of 3i Atlas, estimating a modest nucleus size, while SphereX's infrared data revealed the shocking possibility of a 46-kilometer core. The James Webb Space Telescope, with its unparalleled resolution, could soon join the effort, offering spectra that might pinpoint the exact composition of the coma and nucleus. Ground-based telescopes like those at the European Southern Observatory Observatory are tracking 3I Atlas's motion, while the Vera C. Rubin Observatory, now in its commissioning phase as of September 2025, is poised to scan the sky for transients like this one. Amateur astronomers are also playing a crucial role, using backyard telescopes to capture images at coordinates RA 14 hours 32 minutes, DEC -5 degrees 12 minutes, contributing to a growing dataset shared on platforms like X. This synergy of professional and citizen science is transforming our understanding of the cosmos, turning 3I Atlas into a global project. Yet, the technology also highlights the limits of our knowledge. The discrepancy between Hubble's and SphereX's findings, small nucleus versus massive core, reveals how much we still don't understand about light, reflection, and cometary behavior. The delay in NASA's data release, whether due to rigorous verification or something else, underscores the challenges of interpreting complex data in real time. As we refine our tools and techniques, 3I Atlas stands as a testament to the power of observation, and a reminder that every answer we uncover leads to new questions. This object, with its mysterious coma and elusive nucleus, is pushing our technology and our imaginations to their limits, inviting us to see the universe with fresh eyes. This is more than a story about a single object. It's a saga of curiosity, of humanity's relentless drive to explore the unknown. Whether 3I Atlas is a comet, an interstellar relic, or something beyond our wildest dreams, it's a beacon urging us to keep questioning. Share your thoughts in the comments. What do you make of this cosmic enigma? Hit that like button to spread the word, because stories like this deserve to reach every corner of the globe. Subscribe for the latest updates as we unravel the mysteries of the universe. The stars are speaking, and 3I Atlas is their loudest voice yet. Let's listen, let's question, and let's discover together.